Hi, this is Suresh Krishnan. I'm one of the technical marketing engineers for Juniper's switching products. In this video, I'll be talking about Juniper's Cloud Analytics Engine, in short, CAE. Before we look into details of the CAE solution, let us look at some of the challenges that we are trying to address with CAE. An application administrator is receiving complaints about performance issues with an application. The application administrator has confirmed that they do not see any problems with the applications or servers. They would like to know if there was any problem with the network that was causing the application performance issues. They open the ticket with the network administrators. The network admins try to understand the application's components and the flow. They identify the network devices that could be affecting the performance of the application, look at the logs for each of the network devices, and correlate the logs from all of these different components to identify the root cause of the problem. Eventually, the root cause is identified and fixed. The problem with this approach is it is user-driven. Network or application administrators are expected to have a good understanding of both environments. The manual approach is error-prone and time-consuming. A lot of these tasks are repetitive and automatable. In overlay or underlay use cases, troubleshooting network performance for overlay traffic becomes more complicated because of the limited visibility for underlay devices. These are some of the challenges that we are trying to address with CAE. The key driver for CAE is the ability to reduce the time and expense associated with IT operations. Juniper's CAE solution uses network data analytics to improve application performance and availability. It includes data collection, analysis, correlation, and visualization, helping different operation teams to better understand the behavior of workloads and applications across their physical and virtual infrastructure. With CAE, IT teams get an application-centric view of their network status, improving their ability to quickly roll out new applications and troubleshoot problems. This helps the business by reducing costs associated with manpower and downtime, as well as improving end-user application experience. CAE is a single integrated analytics solution providing an application-centric view of network statistics compared to other solutions that require third-party functionality to be pieced together. At a high level, CAE addresses the following requirements: application or virtual machine visibility and performance management, capacity planning and optimization, troubleshooting, and root cause analysis. Now, let us look at the components of the CAE solution. CAE has the following components: Compute Agent, or CA in short. Compute Agent is the component that resides in the compute domain. Compute Agent can be installed on physical hosts or hypervisors or virtual machines close to the compute domain. Compute Agent is the component responsible for probing and collecting application-specific network statistics. The second component is the network device in the application path. CAE feature in Junos is responsible for understanding probes from compute agents and sending the necessary information back to the compute agent. Junos is also responsible for sending high-frequency interface statistics to the DLE. The third component is the DLE, or the Data Learning Engine. DLE is the component that is responsible for collecting and aggregating information from compute agents and network devices. DLE provides the ability to deploy CAE in large environments. The last component is the orchestration platform. In this case, Juniper's Network Director. Juniper's Network Director provides the GUI for initiating requests and is also responsible for visualizing the data collected from compute agents and network devices. The compute agent and DLE are based on open APIs. The compute agent exposes open northbound web API. You can use Juniper's DLE and ND to work with CA to collect the application-specific or VM-specific network statistics, or you can make your own custom orchestration platform communicate directly with the compute agent using the open web API. Similarly, the DLE provides an open northbound REST API. You can either use Juniper's Network Director or a custom orchestration platform to communicate with the DLE. Currently, CAE can be used for the following use cases: application flow path analysis for applications running on bare metal servers, VM to VM traffic analysis, underlay or overlay correlation. In this video, we'll look at how CAE can be used in the first use case, which is the application flow path analysis. Let us see how CAE provides application flow path analysis. In this example, there are three applications: the red app, the green app, and the blue app. The orchestration platform and DLE instruct the CA to run traces for these applications. The CA sends probes across the network, simulating application traffic. The network devices in the path respond to these probes and send information back to the CA. The CA now has the flow path information for each application. Also, the CA has a rich set of network statistics and device statistics for the devices in the application flow path. As shown here, the CA has collected the following information for each hop in the application flow path: the timestamp for probe ingress interface, hash computed egress interface, egress buffer and queue statistics, interface error statistics, bandwidth utilization at ingress, ECMP bucket utilization, and also device-specific information like CPU utilization and memory utilization. All this information is collected for every hop in the application path. Now, we'll see a quick demo of the CAE solution for the application flow path analysis. This slide shows the lab setup for this demo. We have two bare metal servers running CentOS 6.5. The compute agents will be installed on these two hosts. We'll use CAE to list applications on these servers and also analyze and visualize the application-specific network statistics for applications running on these servers. There are 4 Juniper QFX 5100 series switches in the path. The interconnects between these switches are layer 3 interconnects. In this demo, we'll be using Juniper's Network Director as the orchestration platform to manage the DLE and the CA, and also visualize the information collected from them. This is the Network Director interface. On the left, we can see that there are 4 servers listed. For our demo, we are interested in the first 2 servers. If I would like to know the application flows on server 2, I would click on the Analyze Flows information. This will list all the application flows on this server. As you can see, there are 4 flows listed on this server. As an application administrator, I'd like to understand the network statistics for this application. To run flows for this application, I will click on the Schedule and Advanced settings. In this screen, you can configure settings for the probes. You can decide the duration for the probes. In our case, we'll run the probes for 10 minutes. You can decide the frequency for the probes, timeout, and the maximum number of hops in the application path. You can also decide if the probe should be run in both directions. You can also see there are 2 options here. The first option, capture flow bandwidth. When you select this option, the compute agent installs a packet count filter on each device in the path. The devices then start measuring the bandwidth utilization for this application on each device in the path. The mirror flows option provides the ability to mirror application-specific traffic to an ER-span destination. In this case, we'll not be using the mirror flows option. For this demo, we'll be using the capture flow bandwidth option. Once you've configured all the options, you can select OK, and then run flow analysis for this flow. At this point, Network Director sent a REST API call to the DLE to run probes for this application flow. The DLE in turn instructs the compute agent using the web API to run probes for this application flow. The compute agent runs probes across the application path to collect network statistics for this application. Once the flow analysis is completed, you can click on View Details to see details of the network statistics for this application path. Here, Network Director visualizes the application path for this flow. Here at the bottom, you can see the latency measurement per hop for this application path. The red line here indicates that there was a path change. This could be because one of the interfaces on the devices failed, or there was a routing path change. Now it indicates the new path that the application is taking after the path change. If you would like to check device-specific statistics for this application path, you can hover the mouse over the device and click on Show Traffic Data. This will show the device CPU utilization or memory utilization when this probe was captured. Also, it shows the ingress port, the egress port for this application traffic. You can also see the network director visualizes the detailed interface statistics for this application path on this device. If you zoom in, you can see there are around 6 alarms on this device. Because this device is in the application path, I would like to know more details about these alarms. To get more details about the alarms on the devices, we can go to Device View, click on Faults, select the device that we want to see the alarms for. Here we can see there are around 6 alarms. And one of the alarms that could be concerning for the application administrator is the port high utilization. Let us recap what we saw till now. With just a few clicks on Network Director, the app admin or operations team would be able to identify the application path, get per hop latency, get detailed device-specific statistics for this application flow, detect flow path change, drill down on issues with devices in the application flow path. Without CAE, this process would have taken hours or days to capture and correlate this information. Also, it would have required the expertise, collaboration, and time investment of senior application and network administrators. CAE can provide this information with a few clicks on Network Director. If there is an important application, you can run a low-frequency trace for the application all the time. This would help in forensic analysis. If there was a problem with application performance, CAE can provide the ability to look at detailed network statistics when the application performance was affected. CAE can also be used for capacity planning before applications are deployed to understand the flow path and network statistics. This would help application and network administrators to decide if the network can handle the new application workload, or if the network would need some upgrades to handle the new workload. You can perform proactive application flow path analysis using the Simulate Flow Analysis feature available on Network Director. You provide the 5 tuples for the new application and also specify the parameters for the probes. CAE will simulate the new application traffic and collect network statistics and visualize it on Network Director. Based on this information, administrators can decide if the network is ready for the new application. Now, let us look into more details on how the CAE components are configured to work together. First, we'll look at how to configure the compute agent. After the compute agent is installed, you must configure the compute agent. In this case, we are using the bare metal server, so we will provide native as option. Ensure that you provide the FQDN for the compute agent. Here, you must provide the network interface name that will be processing the application flows. In this example, it will be ETH5. Once the configuration is complete, you can start the compute agent. You can check the compute agent configuration in the compute agent configuration file. In your setup, ensure that the host name for the compute agent is a fully qualified domain name. This will be very important for Network Director to be able to integrate with the compute agent. Repeat the same process on all the compute hosts in your environment. Now, let us look at the configuration necessary on the DLE for the CAE solution. After installing the DLE, configure the compute agent configuration file on DLE. Copy the contents of the CA agent configuration file from the compute agents and paste it into the CA discovery file on the DLE. This file is in JSON format. The compute agent configurations are separated by a comma as shown here. We start the DLE after changing the contents of the CA discovery file. You can verify if the DLE lists the compute agents by querying the REST API of the DLE. Now, the DLE configuration is complete. Ensure that the firewall policies on the compute agents and DLE allow CAE traffic. Review CAE documentation for detailed instructions. Let us look at the essential configuration on Network Director for the different components of the CAE to work together. First, we must add the devices in Network Director. Go to Device Discovery, discover new devices, provide the IP address or hostname for the devices, and provide the credentials for the devices, and then discover the new devices. Once the device discovery is complete, you should be able to view the list of devices in your environment. The next step is to create the data center. Go to Data Center View, click on Set up Data Center. In this case, let us call it a test data center. In this demo, we are focusing on applications running on bare metal servers, so we'll not be integrating with OpenStack or vCenter. Add the list of devices to the new data center, then click Finish. After adding the network devices to data center, you'll also be able to see the bare metal servers listed on the left. Network Director learns about these servers using LLDP neighbor information from the network devices. So it is very important to make sure that LLDP is enabled on all your compute hosts and also the network devices. Finally, configure the DLE information on ND. Go to System Preferences, Monitoring, the Data Learning Engine settings. Here, specify the IP address of your DLE. After adding DLE to Network Director, we must add the CAE widgets on the Network Director dashboard. Click on Add Widgets. Select the Virtual Machines and Bare Metal Servers widget, and also the Recent Flow Analysis widget. Click on Done. That completes the necessary configuration on all the components of the CAE solution. That brings us to the end of this demo. We'll be adding more videos to demonstrate the other CAE use cases. Thank you very much for watching.